Here is the user's guide for bipolar transistors for the electric circuit simulation program ecsp. On ecsp you can find the transistors here. So this is a NPN and this is PNP. These two transistors are exactly the same. They are just flipped. Here is an example of a simple amplifier. Here there is the transistor. Here you have the additional millicapacitance. You can see here the input voltage, the signal voltage, and here you see the output voltage. So the amplification factor is maybe factor 5 or so. If you want to see the values of the elements, you go here to the menu and then you go to element values on. If instead of the time domain you want to have a look at the frequency domain, that's the way to go. And you see here you have the frequency domain of the output frequency. On top of this curve here you see the amplitude, and here you see the phase. For entering the data to the transistor, you interrupt the simulation, you go back to the time domain, and now you can change the parameters of the transistors. These are parameters from the data sheet, especially these two values on top, which normally are the same for most transistors. Then here you have the so-called yearly voltage. And also here I refer to the literature, and here you have the amplification factors BC and BE. I will come back to what this means. The bipolar transistor model used by ecsp is the so-called Ebers-Malt model. So here you have the base current, here you have the collector current, and here you have the emitter current. For normal operation it's mainly these two elements which are in operation, whereas for the inverse operation it's mainly these two elements. And then around 0 voltage across the diodes you have a certain overlap between these two pair of elements. Now we come to the input parameters which have to be inputted in the input mask. Here you see now for normal operation you have this current amplification factor. So this is the IB times the current amplification factor, and the same applies for the inverse operation where you have the amplification factor BBE. So here you have these two parameters BBC and BBE. For normal operation it's this one which counts. So you see in this case, for example, the input current, the base current times BBC is then the current flowing through the collector. On this graph here you can see the base current of the transistor in function of the voltage across the BE, so this diode here. And what you can also see that the slope of this curve here corresponds to the input resistance of the transistor. And you can also see here then the collector current in function of the collector emitter voltage of the transistor. And you can also see the impact of the yearly voltage. This is an extreme case now. That is how you can directly visualize what type of parameters you input to the transistor. Important before you go and run a simulation in the frequency domain, you should always run it first in the time domain, so that and in the loop mode, so that you can adjust all the parameters, and only then you go to the frequency domain for a simulation there, because otherwise the amplitude will not be represented correctly, most probably. Try it yourself on www.ecsp.ch.